Draw the output waveform in proper relation to the input. Now we're supposed to check how the inverter is going to behave if we are going to apply this square wave to the input. Remember, we said that inverter is going to simply complement the input. Okay? It's going to perform the complementation. It's going to invert. So how are we supposed to draw the timing diagram for this problem? Anytime you want to draw the timing diagram, you're supposed to draw the dashed lines at any time you are going to notice any change at the input waveform. Okay, so anytime we have transition from 1 to 0 or from 0 to 1, we're supposed to draw the dashed line. Okay, so now please notice that this level is the level 0, logic 0, and this level is logic high. Okay, so this is nothing else, just 0, this is 1, this is 0, this is 1, this is 0, this is 1, this is 0, this is 1. Okay, so the truth table of the inverter, we said, is A, X, we have 0, 1, 1, 0. So anytime 0 will appear at the input, output is going to be 1. If I have 1 at the input, output is going to be 0. So if I have 0 at the input, output is going to be high according to the truth table. 0 is going to be converted to 1. And anytime I have 1 at the input, output is going to be low. And so on. I have 0, so 0 is going to be converted to 1. 1 is going to be converted to 0. And this is going to be 1. 1 is going to be 0. 0 is going to be 1. And 1 is going to be converted to 0. And this is my output waveform, which is basically the solution to my problem.